All right, today we're going to finish up section 8.3 about similar shapes by looking at these pictures. So I'm going to take this cross-country picture, duplicate it, and I want to make a picture that's a different size. But I'm going to stretch it so that the left side and right side are twice as long as the original, but the width is the same as the original. As you can see, these would not be similar shapes. Not all of their sides have grown or been reduced by the same amount. Now I'm going to do the same thing again, but I'm going to make the top and bottom twice as long and leave the left and right side the same. So as you can see, my original picture, which looked like this, and my new picture are not similar. Everyone in the picture looks wider than they are in real life. Now I'm going to take the original picture, I'm going to duplicate it, and I'm going to make it twice as tall and twice as wide. So if I made a ratio of the new picture's height, it's 2 of the original pictures tall compared to 1 of the original pictures tall, and it's 2 of the original pictures wide compared to 1 of the original pictures wide. So you can see that the scale factor, or K, is 2 to 1. Now we need to look at the perimeters. If I was going to find the perimeter of the original picture, I could say that it's 1, 2, 3, 4. The perimeter of the new picture is 1 picture tall, 2 pictures tall, 3, 4, and then there would be 5, 6, 7, 8. So the original picture had a perimeter of 4, and the new picture has a perimeter of 8. So the ratio of the perimeters is 2 to 1, which is the same as the scale factor. Now we're going to look at the ratio of the areas. So if we say that the original picture has an area of 1, how many of the original pictures does it take to cover the entire new picture? And it takes 1, 2, 3, 4. So the area of the new picture is 4 times the area of the original picture. So if you look here, the ratio of the areas is 4 to 1. The pattern that we're learning is that's the scale factor squared. This time I'm going to take the original picture and I'm going to duplicate it, and I'm going to make it twice as tall. So the ratio of the right side and left side are 2 to 1 in comparison to the original, and 3 times as wide. So the ratio of the top and bottom are 3 to 1 compared to the original. These pictures are not similar. Finally, I'm going to take my original picture and I'm going to duplicate it, and I'm going to make it 3 times as wide and 3 times as tall. And you can see everyone in the picture looks like they did in the original picture. Now, if we compare the perimeters, if the original picture had a perimeter of 4, and the new picture is 1, 2, 3, 4, 5, 6, 7, 8, 9 along the bottom, 10, 11, 12 going up the right side. The new picture has a perimeter of 12. The ratio of the perimeters is 12 to 4, but when that is reduced, it matches the scale factor. So changing a picture by a certain scale factor does not change the perimeter differently than that scale factor. As every side grows 3 times longer, the total perimeter is 3 times longer. Finally, when we compare the areas, we made each side 3 times longer. How does that change the area? Or how many original pictures will it take to cover the new picture? So it's going to take 1, 2, 3, 4, 5, 6, 7, 8, 9. So the area is 9 times bigger, which is the scale factor squared.